And here we go. Okay. We are off. Preston, if you're watching this, we miss you. Oh, I didn't. Did I? What? Whoa. So Preston is watching. Emily says she enjoys the extra elbow space. Meaning if you want to take a couple days off, I want you back, Preston. I miss you, buddy. All right. So, a boardwalk is parallel, so I'm going to draw this out, and then we'll talk through and why it matters. And, you know, you can complain about for a while. That's okay, too. We can express our distaste for the type of problem. But we'll see why it's important as well. A boardwalk is parallel to and 200 feet inland from a straight shoreline. So, I'm going to have a shoreline, which is water. And there's a shark that lives in the water. That just makes problems more interesting if you draw a shark. Okay, has nothing to do with it. But it's more exciting now. So, there's a boardwalk. Everybody know what a boardwalk is? And it says it's 210 feet inland. So this distance right here is 210. A sandy beach lies between the boardwalk and the shoreline. So this is sandy beach. A man is standing on the boardwalk. He's exactly 750 feet across the sand from his beach umbrella, which is right at the shoreline. So he's got this umbrella right here. And he is 750 feet from that. So I think that this problem is basically straight from the book. And I've that's the diagram that they give you in the book, basically. Here's the deal. He can walk 4 feet per second on the boardwalk. And he can walk 2 feet per second on the sand. Why is he slower on the sand? And sand is harder, you know, especially if there's a lot of it, like if it's real soft sand. Also, maybe it's really hot. I remember one of the first times I walked in a real sandy beach down in Florida, there were a lot of jellyfish guts as well. Anybody else experience that? Yeah, jellyfish guts. It's kind of gross. And then sometimes the jellyfish hasn't died yet, so you're worried you're gonna step on it and get, you know. Do you know what you're supposed to do if you're supposed to pee on yourself? Yep, that's the deal. If you get stung, you should urinate on yourself, and if you're in a position where you can't urinate on yourself, somebody else should urinate on you. I'm not going to Florida with any of you. All right. Isn't that in a movie? Was there a popular movie that came out like that? Oh, really? The show Friends? Okay. All right. So no jellyfish on this one. But here's the problem. He wants to walk on the boardwalk and at some point veer off so that he reaches his umbrella in exactly 4 minutes and 45 seconds. Now, that sounds absolutely absurd, doesn't it? It's like, come on, just do what you want and you'll get to the umbrella, right? Well, here's where it does come into play, and this is where the problem actually finds its origin. Well, not necessarily this exact situation, but one like it. Let's say that a lifeguard can run 15 miles an hour on the sand and can swim at 4 miles an hour in the water. If they spot a person drowning, how long should they run on the shore until they veer off and swim to the person, so as to minimize the amount of time before they get there? And that's actually a calculus problem. It's a little bit more difficult. I don't think that a lifeguard would actually, you know, calculate that through. But mathematicians have been able to say, hey, if you're in that situation, here's a rough idea, a rough estimate of when you should actually approach the person that's drowning. No, but you can come up with kind of shortcut ways to estimate about when is the right time. So those are important things, right? Somebody's life, that's important. Okay, so he's going to walk, and then all of a sudden veer off. Is this problem in minutes, seconds, or hours? Seconds. So we should probably convert his time to seconds. 4 minutes, 45 seconds. That's the same as 285 seconds. We do not know how long he walks on the boardwalk, do we? We don't know. Okay? We'll call that B. We don't know how long he walks on the sand, do we? We'll call that S. Would you agree that the time on the boardwalk plus the time on the sand should equal 285 seconds? We all squared away there. Well, we don't know the distance and we don't know the time, but we do know his rate on each one. So this is a distance, rate, and time problem. All right. Now, are we concerned about the amount of time at which it takes him? Time on B, time on sand. So if we have this equation, rate equals distance over time, which variable should I solve for? Distance is a nice variable to know because that's what we are eventually trying to calculate. However, the problem says time plus time equals 285. So I want an expression for his time on the boardwalk. I want an expression for his time on the sand. So I'm going to solve for T. R times T is equal to D. If I multiply both sides by T, divide by R, and I have T equals distance divided by the rate. So, do we know the distance that he walks on the boardwalk? So we'll call it what? B. Do we know the rate at which he walks on the boardwalk? 4. Plus, do we know the time on the sand? Do we know the distance on the sand? No. We'll call it S. Divided by 2 equals 285. That doesn't look so bad, does it? So what to do, what to do, what to do? You can't have two variables, can you? You can only have one. So we need to get rid of this S and have something that involves the variable B. Well, here's where we need to do some work. Let's try to figure out some unknowns here to help us out. Can we find that distance? How? Very good, Alexa. A squared plus B squared is C squared. So we'll say A squared plus 210 squared is equal to 750 squared. Everybody okay with that? Let's take out our calculator, and what we will do is 750 squared minus 210 squared is that. What do I need to do to that? Now, I see a lot of people in pre-calculus pressing more buttons on their calculator than they need to. When you want to square root that, just press square root and then grab the answer button. So if you go second that negative sign, ANS, that means it's going to input the answer that you just came up with. So you don't have to keep on punching in numbers. Raise your hand if that's new to you. Okay, all right, good. There you go. Important, especially when you get to trig and we're dealing with many, many, many decimals. You definitely want that. So we get 720. So that length is 720. Everybody all right with that? All right, so I'm closer to getting at this S. How about this? If that's B, if the green line is B and the blue line is 720, can somebody give me an expression for the red line? Very good. Sini says 720 minus B. Ask the question. Well, the answer button? That's okay. Watch. Let's say you want to take 5 times the answer. Go second, negative sign. And that grabs the answer. And it'll take 5 times 720. We'll use it again. We'll get more chances. Okay. So now, look at this. I could solve for S in terms of B by using what? The Pythagorean Theorem. Now it's going to get ugly, but that's okay. We'll actually be able to solve this problem. I'm going to do it on another sheet so that we can see exactly what's happening. I'm going to do a squared plus b squared is c squared. So a squared plus b squared is c squared. A, we said, is 720 minus b. B squared is 210 squared. And what variable was in the place of c? S. Now we want to get rid of that S and we want to put in the place something that has a B in it. Can you do that here? What would you do to both sides in order to solve for S? Very good. You want to square root both sides. Now, the common thought that people have is at this point, they would like to square root the 720 minus b squared and the 210 squared. You can't do that because you got the plus sign in the middle. So we just have to leave it like that. I know it looks ugly, but I know your algebra skills because you just tested on it, and you're going to be able to work this problem out, no issues. The fact is that this is now S. And so we're going to write our new equation back on that side. By the way, you might have to attach a separate sheet of paper today because this does get quite lengthy. Whoop. Don't do that. So, let's write our new equation. We have b over 4 plus, and instead of s, we said we're going to have the square root of 720 minus b, quantity squared, plus 210 squared, all over 2 is equal to 285. Are you okay with that? Caitlin says no. Oh, okay. Excellent question. Okay, let's do it this question exactly here. What you want to do is you want to take off that and that, right? So watch. Okay. Okay. Let's say you got 25 minus 16. What's the square root of 25? What's the square root of 16? 5 minus 4 is 1. But if you actually evaluate this, 25 minus 16 is 9, and square root of 9 is 3. So if you do just take off the square root, or the squared sign, so 5 squared plus 4 or minus 4 squared, you can see that you do not come out with equivalent expressions. If there was a times sign in between these, then it works out. But if it's subtraction or addition, you can't just do that. Okay, you can't just do that. So we are left with this equation. We have nothing else to set up with the problem. All we need to do is solve this problem in front of us. B over 4 plus the square root of 720 minus b squared plus 210 squared over 2 equals 285. So let's just talk about this. I know that that looks really, really bad, but let's just deal with how we can make it look better. Okay? Question. So that equals s squared, right? What's the square root of s squared? S, right? So s is that thing. So what I'm doing now is I'm going to take that thing and plug it in. Oh, don't do that. Instead of that s, I wrote that thing. Got that? I don't like the fractions. How do you get rid of fractions? Multiply through by, what is the common denominator among these? 4. Let's get rid of the fractions. I multiply the top through by 4. It will go away. 4b over 4 is just b. 4 over 2 gives me just 2. Square root of 720 minus b. 720 minus b squared plus 210 squared equals, and 285 times 4 is 1140. That looks better than it did, didn't it? You don't like the square root, do you? Let's get rid of it. And you learned last unit, you tested on this, in order to get rid of a square root, what do we do to both sides? Square it. But you should only have the square root on one side, right? So, because when you do the Pythagorean Theorem, you have to square root both sides. So s squared or c squared was equal to a squared plus b squared. So when we solve for that s squared, we got to square root both sides. So I've got the square root of all that. So now I am going to deal with this beast in front of me. I need to get rid of the square root sign. And if I want to get rid of it, I'm going to have to move everything else over and just deal with that. So let's do that. 2 times the square root of 720 minus b, quantity squared, plus 210 squared is equal to 1140 minus b. If there's multiplication attached, I can square both sides. That's okay, because 2 squared is 4. So now I'm going to do the magic of squaring both sides to get rid of my square root. If I square, the 2 becomes a 4, and the square root goes away. So you have 4 times everything that's left in the square root, which is 720 minus b, quantity squared, plus 210 squared, and that's equal to, well, now we're going to have to FOIL that out, aren't we? Let's just FOIL it out and get it over with. On your take-home test I give you, I do a similar problem. However, I don't give you such big numbers because I want to make it a little bit easier on you. So, very good. If you take that 1140 and times by 1140 or square it, you get that 1,299,600. And you guys know that 1140 minus b, quantity squared, is 1140 minus b times 1140 minus b. So when you take the 1140 times 1140, you get that 1 million number. And then you're going to have 1140 times negative b and negative b times 1140. What's that going to give you? Very good. Negative 2,280b. And then you have negative b times negative b is b squared. So I know that they're big numbers, but really that's just a second degree equation. And you know how to solve second degree equations. You set them equal to 0 and then you do one of three options. What are those three options? Factor, complete the square, or quadratic formula. And we're going to actually use our calculator to solve the quadratic formula just like that. That can be no work at all. All I have to do is, simplify the expression on the left and get everything over to one side. So we did the right-hand side. Let's FOIL out the left-hand side and see what we get here, okay? So we work with this. I have 4 times everything through here. So we'll write 4 times, and now I have to FOIL out 720 minus b, quantity squared. So I have 720 minus b times 720 minus b. Let's work that out. What's 720 times 720? 518,400. If we're off by just one digit, we'll get problems. So I'm going to trust you guys on that. Okay, then you have 720 times negative b and 720 times negative b. That will give you, good, negative 1440b. And then you have negative b times negative b is b squared plus, what's 210 squared? How about this? We just got that same thing up above. What do you want to do now? Times everything by 4. That's a good idea. Let's multiply through by 4. By the way, this is the biggest problem you get this year. We're not going to go through another problem this large. But if you take calc next year, we'll do one slightly bigger. 4 times b squared is 4b squared. Yep, let's do that. So we've got 518,400 plus the 44,100, and you're going to multiply that by? Is that 2.25 million I get? Yep. So minus 1440b plus 2.25 million equals, we said that b squared minus 2280b plus 1,299,600. So yeah, there's big numbers, but really we're just combining like terms here. And you guys are one step away from being able to use your calculator in the quadratic formula. Question? Oh yes, thank you. Grace caught it, thank you. We would have been out of luck there. So everybody see what Grace saw? Got to take that 1440 times 4. Anybody got it? Is it 5760? Okay. Good job. Okay, so let's put everything on the left-hand side. Let's subtract the b squared, and what do you end up with? 3b squared. So my b squareds are gone. Now let's add 2,280 to negative 5,600. What do you get there? Negative 5,760 plus 2,280. And we get 3,480. Negative 3,480. And then I take my 2.25 million and I subtract off of that 1,299,600. 950,400. Well, now it's just a quadratic set equal to 0. You guys know how to solve that. We said you factor, use a quadratic formula, or you complete the square, or you can turn to your handy-dandy calculator. And some of you guys have this plugged in from last year. If you don't have it, I could give it to you today. You press Program. I press Enter on Execute the Quadratic Formula. And I press Enter. Raise your hand if you already have this in your calculator. Okay, for those of you who don't, we can try to put it in together if you want. What's my A value in this situation? 3. What's my B value? Maybe 3,480. And my C value is 950,400. And I get 720 and 440. I have two solutions. It's a quadratic. If we simply go to our original problem and look at what the B value is, B is right here, 720 or 440. Is it possible for him to walk 720 feet? Yep, he would walk the entire distance, right? And then he would turn and head towards his umbrella. So 720 is possible. Is it possible to walk 440? Yep. So he's got two options. If the sand is really hot that day, he could spend most of his time on the boardwalk and then head to the umbrella. If it's a nice day on the beach, then he can just go 440 and head to the umbrella. And those are his options. And those are the two answers. So he's got two solutions. When I set this up on the video, it only lasts 8 minutes as opposed to probably the 25 minutes it took us. And I want you guys to know this. If you watch it, I do something just slightly different. Instead of B there, I put B there. And the algebra works out nicer. Why did I switch it this year? Because every year people want this to be B. When I make that B, everybody's like, why would you make that B? I want that B. I'm like, well, the algebra works out easier. Like, how do we know that? So I just decided, fine, we'll have that end up as B. You come up with the same solutions. The math does work out a little bit better this way, but all in all, that's the type of problem that if you want an A on your homework test, you need to be able to follow that one through.